set, right, to store. And we have a group of values to store, but with each value, we want to associate what does it mean, like attribute and value. In such cases, we want to have mapping type. So in such cases, we use dictionary that we see here. Okay, that is what we have discussed so far. But use later we are going to see that we'll be writing code statements to find device details. We come here and go to connect to the devices. Come here and then sending.
Hello.
Yeah.
Hello. Nested dictionary is possible, right?
What?
Nested dictionary.
Recording in progress.
Yes, very much possible.
Okay.
We can have dictionaries inside the dictionaries. But yeah, to keep things simple at this point of time, I didn't mention. But yes, just like how I have a list here, this itself, this can be a dictionary.
Oh, okay. If nested dictionary, how to find key value from nested dictionary? How to get key and value from nested dictionary?
Yeah. So let me move on so that for now, questions you please ask on chat, and at the end we can have the discussion. I'll just show you how to deal with the nested dictionaries. And someone is not getting my voice. Yeah, this is an example of nested dictionary, right? This is the way we can get the values. Okay. So this private IP is a nested dictionary. So let's print out print private IP. My voice is low. Okay, let me. Okay. Coming down. And you're executing 8. Okay, so this is a nested dictionary where this is the key, the element, the value which is associated with this key itself is a dictionary, right? So let's so this okay, let me comment these statements. Okay, so this is a nested dictionary. So now first let's get this key. Okay, what we got is a dictionary. Now how do we get value from this? Same way, whatever we have done, we'll just extend on top of it, right? Now this entire thing is a dictionary. So we can store it in sub PICD is equal to this. Now how do you, this is a dictionary. Now how do you get values from this? Same way of IP. If you don't want to store, you don't want to waste unnecessary variables, replace it here. Only thing is, we in the initial stages, this might look a little confusing, right? What is happening? What is this? What is this? What is this? Right? So if you are getting confused, then take this guy, put it in a variable, and use that variable so that it improves readability. Because at this point, we are not worried about efficiency, writing efficient code when we are learning. Right? It should be easy to understand. No, we don't have to save this. These can be anywhere. That's the reason we set when we install Python, right? We set it in path so that from anywhere, from any directory, right? I'm in my home directory. From here also, I'll be able to invoke Python executable. Because we can do this, we don't really have to save the Python files in the same directory. We can store them anywhere. Typically, we create a work directory inside that. If you want to learn, we create a folders accordingly, and then we save them inside that. From there itself, we can run them. Just say Python and then start one. Okay, so this is a way we can process dictionaries, nested dictionaries. Yeah. So next topic, assume that there are some statements. We will be filling in these gaps very soon. Assume that there are these statements where we are defining some devices. We have written code to connect to these devices. We have written code to send read commands to the devices. And finally, we have written code to sending config commands to the devices. That's our ultimate goal, right? Being able to automate the device the normal flow of execution of this is top to bottom, which means it starts from here, then all these statements they get executed in the order in which they are specified: first line, second line, third line, fourth line, fifth line, and so on. It goes like this, right? But let's say here, right, sending read commands and sending config commands to the devices, right? There could be slight variation here, right? We have different type of devices, right? Like routers, switches, firewalls, etc. And now the read commands that you are sending is not same for all, right? Probably there's a different set of commands for each of the type of devices. So how do you handle this situation? Same is the case with config commands as well. How do you handle this situation is, now here you have to do something called as decision control. You have to take a decision. If the device which I'm connecting to is a switch, then send these commands, the switch related read commands or switch related config commands. But if the device I'm connecting to is a firewall, send those commands, probably like updating firewall policies, opening ports, and so on. right? So that is the difference between normal flow of execution and a conditional flow of execution. Right? Here there is a conditional execution. Once you want to make this code generic so that it works with different types of devices, we have to do something called as conditional processing. We have to execute code based on certain conditions. Yeah. Okay. That we call it as decision making. Right? Normal flow of execution is top to bottom, but there could be situations where we need to alter the sequence of flow of execution. One such situation is decision making. Right? You see this diagram. You start from here, start executing, and at this point we got a condition which we need to evaluate. What is the condition in our case? Is it a switch? Right? The answer to that is it a switch is yes or no. Right? If yes, then do this. If the answer to this question is yes, then come here and do this. If no, then do something else. Okay? That we know, we call it as decision making or conditional statements. The way we express them is using, like in English, right? If else statements. The way we write it is if expression. When we say this is expression, this expression evaluates to the result of this expression is yes or no. Yes or no in terms of Python terms is called as true or false. So expression, we say that this expression evaluates to true or false. If this expression is true, then come inside and do this. Else, do something else. Okay? Yes. This is the booleans that come into picture. These expressions always return true or false. Okay. Now I'll define a variable device is equal to device type. Is equal to switch. So I'll say print this is a switch, right? So in sequence of execution, in the normal flow of execution, what happens? First this statement executes, then this statement execute, then this statement executes. This is fine because the data is like this. Okay. But suppose somehow this got modified to router. Execute this. It keeps saying this is a switch, this is a switch. So we need to alter it. If the device type is switch, only then you print this. So I'll put a conditional statement. If device type is equal to switch. Right? There's a slight syntax change that you'll have to get used to. If device type, this double equal to is like comparison. Here this single equal to is assignment. Single equal to is assignment. Assignment means this is a variable. Into this variable, we are assigning this value. To this variable, we are assigning this value. This double equal to means equality, comparison. Check whether device type is equal to switch. That's what this double equal to means. And this colon says that yes, I'm starting my if block. right? This is like main block. Device type is defined in the main block. The second statement is in main block. This statement is in main block. But whatever comes here, like they belong to the if block. Right? So we slightly push them inside. This we call it as indentation. In Python, we tell that, okay, if the statement is like this, does this belong to if statement or does this belong outside? We don't know. So to say that no, this statement belongs to if block, I'll slightly push it inside. Okay, which means if device type is equal to switch, then do this. Only then do this. Now this we call it as an expression, device type being equal to switch. That results in true or false. Right? If in this case, what happens? Here it is saying router, but I'm checking, is it a switch? So it says no, or it says false. The expression, the result of this expression is false, which means this statement will not be executed, which is what we want. Indentation, typically we press a tab, four spaces. Right. So instead of typing those 4 spaces, we just hit a tab. Tab by default is 4 spaces. And it really doesn't matter. You can use 1 space, 2 spaces, 3 spaces, 4 spaces, any number of spaces, but you have to be consistent. At the top, you cannot use 1 space, and at the bottom, you cannot use some other spaces. If you're using 1 space, you have to stick to throughout your file to 1 space. If you're using 2 spaces, 3 spaces, 4 spaces, you have to stick to that. Okay, that's the only thing you need to keep in mind when it comes to indentation. Let's execute this. It doesn't do anything because I've defined a router and I'm checking, is it a switch? If it is a switch, then do something. This is fine. But what if this is not a switch? I've handled only one part of the problem. I have to handle the other part of the problem as well. Right? What if this is not a switch? I'll say, if this is not a switch, then go and check something else. Else, which means this is false. When this is false, it comes into else part. Right? This is not a switch. Okay. So I'm saying if device is equal to switch, do this. Else, this is not a switch. But there's like black and white, either this or that. But I have some gray areas, right? I have routers, I have firewalls, etc., etc. So can I say that else this is router? I cannot say that, right? It may or may not be router. Again, in this case, it works fine because if this is a router, it says this is a router. But suppose this is firewall. I'm defining the type is coming as firewall from somewhere. This is router, which is wrong. Right? So I have to this either device type is equal to switch or it is not equal to switch. I have not considered the possibility of it being anything else. So I need to slightly modify the code. I will say if device is equal to switch, then do this. Else, if device is equal to something else other than switch, then do this. So that else if, how I represent in Python is short format. I'll represent it as elif. Elif, device type, router, then print sys router. and this we can continue. If device type is equal to firewall, this is a firewall. Finally, we have exhausted. Okay, we are handling switches, we are handling routers, we are handling firewall. But something else has come, like it's like a Linux server has come, which I'm not Linux admin, so I don't know how to handle that. To take care of that conditions, right? Any condition other than what we can handle, we push it into else. And accordingly, we have to say, I don't know what type of this device is, right? I'll say, let's say unknown device. Because I know I can identify only switches, routers, and firewalls. I'll say if device type is switch, then say print this is a switch. Else if device type is router, print this is a router. Else if device type is firewall, print this is a firewall. Else, which means none of the above conditions are true. So there's like a last resort. Else, which means it can be anything other than these. I'll simply say unknown. Okay. Now it works for switches as well. When switch comes, it says switch. When firewall comes, it says firewall. We've already seen. When router comes, it says it's a router. When something else comes, it says unknown device. Okay. No, we can have any number of elifs. You can go on and on. But the final one should be, I mean, you can skip also if you do not have that final condition. But this else cannot come somewhere in between, right? After else, I mean, after if, you cannot have else and then elifs, right? The order is if, elif, 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 any number of elifs and else. Okay? Only one if and one else can be there. If you have any other multiple conditions, all of them have to be elifs. Now I can also have nested if. Right? If the device type is switch. Thanks for reminding me. No issue as such. You would have missed handling the possibility of all the above conditions not being satisfied. Right? It's not mandatory. You can as well skip it, but then there's a hole in your logic. Now, I know there's a switch. I want to further check gap in the log. Okay. If device type is switch, then we come inside. Now I know that it's a switch. I further want to check: is it Aruba switch? Is it a Cisco switch? Is it a Juniper, etc. What I have to do? I have to put another if. Right? If vendor, or it is a switch vendor. Just some hypothetical examples just to show the concept. If vendor is equal to Cisco, again push this guy inside. You see this indentation? This if is inside this if. This print is inside this if. Okay. I said this is a Cisco switch. Again, this story repeats. Elif SW vendor is equal to, let's say, Aruba or Arista. There's a Arista switch. Yeah, this we call it as nested if inside a if. Okay. That's about conditionals. Now there is one thing, zero, right? The truthiness, we call it as truthiness, or truthiness and falsiness. Truthiness of zero is always false, right? Truthiness of anything else other than zero is always true. Same way, truthiness of none is false. So when it comes to numbers, zero always evaluates to false. Anything other than zero evaluates to true. When it comes to strings or any other objects, none always evaluates to false. Anything other than none evaluates to true. Same way, like let's say you're comparing lists, blank list evaluates to false, non-blank list evaluates to true. Okay, if you want to see what am I talking about, let's create another conditionals file. False num zero. And so if false num rest is if you want to check their truthiness, we can convert them into bool. Once you know if bool is returning true or false, then we'll know how it works in F. True now. Anything. Let's say 5. Zero evaluates to false. Anything other than 5, anything other than 0 evaluates to true. This is about numbers. Now about strings. False str blank. True str. Anything other than blank. Simplicity sake, we call it as F. We call this as B, so that it will be easy for me to. And we have seen it for numbers. So let's comment this out and continue. We'll call this as F. We'll call this as Q, so that I can use these statements. I will use these statements. blank string is false. Non-blank string, anything other than blank string is true. Copy this, comment it. This is a blank list. This is a non-blank list. This is false. This is true. Now, why this is important is, yes, empty string is false. Now, why this is important is you can write this kind of statements. If T, then do this. Instead of again comparing if this is equal to 0 or not, right? If it is blank, if my string is blank, there is nothing for me to do, right? And I know that blank strings become false. So if do something, process that string only if it is not blank. Okay. If not F, colon is a block separator, right? Now, if I leave it like this, I don't know where, whether I'll be continuing something else, putting some other condition. So we put a colon, say, yes, I have completed defining my condition. Then next line onwards, all the statements, I'll put all my if processing statements, and they will be slightly indented inside. I select all of them, all the lines, and hit Control / which is below the question mark. So that's a shortcut to comment multiple lines in Visual Studio Code. In most of the editors, it is becoming standard nowadays. Control / It's like toggle. If it is commented, it will be uncommented. If it's uncommented, it will be commented. Okay, so that is, we call this as truthiness, falsiness. So it's like this a quick way which is provided by Python to check. Like I read some data from a file, right? Let's say I'm expecting some string to be read, but there was a blank string in the file, and I don't want to go ahead processing it will cause errors. So first I'll check whether the string is non-blank. A quick way to check is with this, right? If it's a blank string, it will become false, right? So I'll process only if it is not false, right? Now this will not okay, this will go inside because F is false, not F. So I should say if F, only then process. So in this case, F is false. So I'll put some element. Now list will be processed because if this is no more false. That should be good enough for this thing. If else we have covered. If any else we have covered. Then we come to something called as loops, right? When someone, without drawing any conclusion, when someone goes on saying the same thing again and again and again, right? We say, yeah, he's getting into a loop, right? So it's that we want to. So there are some times when we want to do something again and again and again, right? Best example is we have 10 routers which we want to configure with, let's say, a specific VLAN or interface, right? How do you go about doing it? You won't write 10 different programs, right? One program to configure router 1, second program to configure router 2, third program. You won't write 10 separate programs to configure 10 routers, correct? Because whatever you do for one router, it is the same process that you need to do for all other routers. Only thing is probably the connection details will vary. Right? The username, password might vary. The IP address will vary. Correct? So in such cases, we use something called as loops. We go in a loop. Every time we are in the loop, we take one router, check what are its details, connect to it, configure it, finish it off. Again, get into the loop, move to the next router. Okay. So this is a schematic diagram for, no, not this. Why this is coming in? Where is mine? I start here. Now there are two types of loops. There is something known as for loop. There is something known as while loop. What is the difference? I'll just explain in a minute. Right? For loop we use whenever we have a sequence to be processed, like sequence as in collection. Right? I told you there are 10 routers to be configured. So you use for loop. For each router in this collection of routers, do something. That's how we define. For each router in collection of routers, configure the configuration statements. Right? It starts here, comes here. So here, instead of coming across a single router, you come across multiple routers. Now, what do you do? Take the first item. Take the first router. Right? Execute the statements. Take the first router, execute the statements. Now there are more items, more routers in the list to be processed. So what you do, you go back. Right? Start here. Somewhere you came across, instead of a single router, you came across a collection of routers. What do? You take the first item in the collection, move ahead, execute the statements. After finishing it, don't go any further, because you have more routers to be processed. So what you do? You go back. You go back and pick the second item. Come here, execute the statements. Go back, pick the third item. Execute statements. Go back, pick fourth item. Execute statements. Suppose there are only 4. You go back, you see, yeah, there are no more elements in the sequence. Right? All four were there. All 4 have been processed. You continue further. Right? You come out of this loop and then move ahead. Making sense? We do not have a switch case in Python, but we can simulate switch case. We can write using ifs. We can normally write. This is like for loop. Okay, so that's where we use for loop. Let's see for loop in action. Eleven for loop. Right. I have a list of routers. R1, R2, R3. Now you want to do this. Just before you connect to router, you want to print connecting to router R1. Once you connected successfully, this we call them as log statements. Right? We keep logging what is happening. As and when we keep doing some work, we keep logging it so that if something goes wrong, we know till where things went successfully, from where things started going wrong. Right? Connected to router R1. Let me say configuring R1. And we'll say after it is done, print completed. Right? Now, suppose in between here the connection statements will come. Then here the configuration statements will come. Now this block of code has to be executed for all these things. So what we'll do, we'll put this in for loop. For, now there are multiple routers. So we'll say for a general term, router in routers. For router in routers. What is this routers? This router is the list of routers. Right? So to say that, yes, this is my for statement. I'm starting my block. I put this colon. Once I put this colon, all these statements should belong to for block. So I'll push them inside using indentation. Right? Now this R1 is no more correct. Right? In the first case it will be R1, in the second case it will be R2, in the third case it will be R3. So I need to make it generic. I need to replace it with variable name. Which variable name? This guy. Because when things go in loop, first time this router becomes R1. Second time, first time this router becomes R1, then these statements will be processed. Then again, since there are more elements in the for loop, again it goes back. Now this router becomes R2. Again, it goes back. Now this router becomes R3. So this router is like a temporary variable in which these elements are stored when the loop is being processed. So instead of hard coding the variable, we'll replace it. Best way to replace is we learn the formatted string. Right? So we'll put like this and say this is not a normal string, this is a formatted string. It says connecting to router R1, connected to R1, configuring R1, completed configuring R1. Done. R1 done. Then it moved to R2, connecting to R2, connected, configuring R2, configured, done. move to R3. So with just 4 lines of code, we can process any number of devices. I mean 4 as in this case it is 4. Probably whatever is the required number of these things. Let's say I have 10 like this. Or let's say just 2 more. R4. R5. I don't need to modify my code anymore, right? This code is generic and it works for every element that is new element that is getting added. So when I run it, and from R1 all the way till R5, everything gets processed. This router takes value because we are saying for router in routers, right? In is membership operator. What is this routers? Routers is list of values. Right? When you say for router in routers, obviously it goes to routers and first it takes the first value. After finishing the first value, again it goes back, takes the second value. After finishing second, again it goes back and takes the third value. Okay, that's how for loop works. Till all the elements are exhausted, after finishing these statements, again it goes back and picks up the next element which is available. Now this name doesn't matter. I can say I. But if I say I have to use everywhere it as I. But this I, J, K doesn't make much sense, right? We are talking about routers, which is a list of routers. So it makes sense to call this temporary variable as router, because in each iteration, what I'm dealing with is one single router. We can say that, but it has to store the value, right? And we are using it as a variable. So that's why we call it as a temporary variable, because it does not have existence outside this for loop. It is a temporary variable which holds each item of the list when the list is being processed. Okay, this F means that, okay, suppose if I don't put F, right? Let's see what happens. What happened? It printed this router as it is, right? So instead of printing it as it is, you get the value of the routers is a variable. You get its value and substitute here, which means you format the string by substituting this router with the value of the router. To say that, we put F, which says that treat the string as a formatted string and not as a normal string. Okay. So this is one kind of for loop. Now there's another kind of for loop. Let's say I want to do something 20 times, 30 times. Simply certain number of times I want to do. I don't have any list as such, but I want to repeat something for some number of times, 10 times. Right? In that case, what we do is like we have something called as range. Range is a built-in function which will return a range of values starting from the starting value up to the ending value. I say up to the ending value because it won't include 11 in the resulting range. Okay. So you print your range. It says like that. But now this becomes like our collection item. We can use in for loop for I or value in range 1. Print value. And it prints 1, 2, 3, 4, and so on, all the way up to 10. So these are two ways of these things of using for loops. Now, probably a better use case for this kind of thing is, now you have a list of routers, right? Instead of saying this, I'm processing router 1, router 2, router 3. Let's say you want to say, I'm processing first router, second router, third router, and so on, right? Which means you need to know how many elements are there in this routers list. How will you know that? 11 is not printed because upper limit is excluded, right? In the range, lower limit is inclusive, upper limit is exclusive. Starts from 1, goes up to 11, but does not include 11. So if you want to define a range of 100 numbers, you have to define from 1 to 101. If you define up to 1 to 100, it will take only up to 1 to 99. Now in range, you have these things also. Like by default, you see it is going one number up. 1, 2, 3, 4. Let's say you want to take 2 steps at a time. You put 2. Start from 1. Take 2 steps at a time. Go up to the 11. Right? Now started with 1. Then it took 2 steps, 3. 2 steps, 5. 2 steps, 7. 2 steps, 9. Now if it takes another 2 steps here, it will reach 11, but 11 cannot be included. So it stops with 10. So stops with 9. You can even say this 5. You can say any number. It just takes those many steps. Now, when this is more useful is, as I said, like you have a huge list. You don't know how many are there. So instead of saying, yeah, I'm processing a generic message like router 1, 2, 3, 4, right? Router 1, router 2, router 3, router 4. So in such case, what we can do is, first we need to know how many elements are there. So we'll get its length, right? Routers, number of routers is equal to length of this list. Okay. Now I have a number. So I'll start my range starting from 1 up to number routers plus 1. Right? I need to go 1 step above, otherwise it will come to number routers and stop. So in this case, 1, 2, 3, 4, 5. So my range will be like 1 to 6. If this list is like 10, 1 to 11. So I'll say something like this. Now I'll say for val in range 1 print connecting to router value. Connecting to router 1, router 2, router 3, router 4, router 5. Okay. What did we do? We have a list. We found its length. Right? In this case, it is 5, which means I need to define my range from 1 to 5. Because range does not include the last value, I define my range as 1 to 6. And that's what I've done. Range of define a range from 1 till number of routers plus 1. Then use your for loop. For value in this range, do something by taking that value. Okay. You have something else known as while loop, which is a little complex, slightly complex. Right? If you have not understood, well and good, no problem, you can ignore it because we don't use it much. But it's very, very, very useful thing in certain situations. Right? Now you have seen if, right? If true. So instead of defining a condition, I'm directly saying true. Right? This true will always be true. Right? Print. This will always be dead. Why? Because I'm saying if true, this true will always be true. So it will always come inside and this will always be printed. Okay? This will always be printed. But because of this if statement, see what happened? It printed it once, right? It came here, evaluated the condition. This condition is true, came inside, executed the statement, and stopped. Right? How the if statement works is, come here, if, evaluate the condition. If this condition evaluates to true, in this case it will be true because the condition is nothing but the true itself, the Boolean value true itself. Then come inside, print the statement, and stop. Replace this if with while. And then see what happens. What is happening? It's going on and on and on and on. And this will never end till my RAM is exhausted. And I have pretty big RAM, so it will not exhaust it so fast. So I'll have to force terminate it. See how many times it printed. Right? So while is a kind of infinite if loop. Right? If will evaluate the condition once, executes the statement and stops. While evaluates the condition, if it is true, it comes inside, right? It executed this. But while is a loop, it's not simple statement. So what it will do? It will go back. Right? In loop, things go back and start all over again, right? So after printing this statement, again it will go back and do what? Check the condition. But this is true. Again it is true. Come here, execute statements, go back, check. Still it is true. Come here, execute, go back, check. Still it is true. That's what is happening. Right? That's why this will keep this kept keep this getting this kept getting printed. But the problem is this will never change. This will always be true. So we are in a situation called as infinite loop. We call this kind of situation as infinite loop. Sometimes people who are writing code accidentally, here I knowingly I put this as true and then wrote this. Sometimes like they'll put some genuine condition, right? Some condition which will always be true, which will somehow always evaluate it true. In such case, they end up with infinite loop. Which means yeah, there's the next topic. So a proper way to write a while loop would be, let's say you want to do something 20 times length. Let's take the previous example. So have this guy. Num routers is equal to line of routers. Okay. Now we want to write the same kind of statement using while. So you'll say I is equal to 0. You will initialize some value to 0 or 1. While I less than num routers. Right? My num routers is 5. I'm starting at 1. So I can count. A more appropriate name for this would be counter. I'll use a counter. Right? You know, in cricket, those umpires, they hold one small device to remember how many balls people have bowled. Because they're concentrating on so many things, right? They won't be able to remember whether this guy bowled 3 balls, 4 balls, right? Of course, the bowler remembers, but everyone else remembers, but it's more important that umpire should remember. So what they'll do is they'll hold a small device. As soon as the bowler bowls this thing, they will press it once. Right? So second ball, they'll press it. So like this, it goes up to 6 presses. And 6 presses are over, it indicates, yes, one over is over. So we can think of this counter like that. Right? We'll start with counter, starting with 1. We'll check counter is less than or equal to number of routers. Right? Now first counter is 1, number of routers is 5. So this statement is true. 1 is less than or equal to 5. We'll say print. Connecting to counter. Okay. Now let me execute. What will happen? Counter is not defined. Yes, spelling mistake. Oh, what happened? Again, I'm into infinite loop. Why? Because the umpire has forgotten to press the button after a ball is bowled. So the poor bowler kept bowling. Right? Yes. We have to increment the counter for the second iteration. Right? We started with counter as 1. We are checking. As long as the counter remains less than the number of this thing, keep doing this. But then we should not forget to increment the counter. counter plus assigns 1. It's like saying counter is equal to, how do we increment the counter? Counter is equal to counter plus 1. That's all we need to do. It executes 5 times and stops. Now, this statement, there's a shorter way to do it. You can say plus assigns 1. It's like saying, okay, take counter, add 1 to it, put it back into the counter itself. This is a shorter form of saying the previous thing. Counter is equal to counter plus 1. So in this case, what is happening? First counter is 1. 1 is less than 5. Come here, execute this. Counter is equal to, it's already 1. 1 plus 1. Now counter is 2. Come here, 2 is less than 5. Execute, increment 3. 3 is less than 5. Execute, increment 4. 4 is less than 5. Execute, increment 5. 5 is less than or equal to 5. Because I put the equality symbol. Execute, come here. Now it is 6. This is where this condition fails. 6 is not less than or equal to 5. So it won't come inside the while loop and it stops. Okay. Now someone said break. Okay. We'll see what is that break. So for any questions, is it too much for people who are new to programming? Is it making sense? Not everything may not make sense at this point till you actually try it yourselves, but hope you are getting like a feel of what we are trying to do here. When to use for, when to use while, when you have a list, right? You want to do something specifically for each item in the list, you simply use for. That's the simplest. For item in the list, do something. But you want to, it's not as simple as that. Somehow you are getting into true false kind of a expression. In such cases, we do not have a choice but to use for while loop. Okay. So these are loops. Now, when we have loops, we should have something known as control statements, because as we saw, things can quickly go out of control if you mess up, which we normally do. Okay. Normally we tend to make mistakes and things can go out of control like we have seen. So we have something known as control statements. That is 30. Okay. Now we have two kinds of control statements. One is break, the most important. The other one is continue. Right? Now, to find practical examples for this would be very difficult. Break and continue. So I'll take some hypothetical examples to explain the concept. Normally, there is one more statement called as pass. This is not exactly a control statement, but I'll explain the concept of this pass. Right. This actually doesn't fall under a control statement, but it is there. We don't know where to place it, so we normally club it with break and continue. Now, first we'll get the pass guy out of way. Let's say I'm writing some logic, right? While some condition here I want to put some statements, some process statements, but I'm not yet ready with my logic. Right? What do I exactly do when this condition is satisfied? I'm not clear. But what is clear is next set of statements. Right? So when you try to execute this, it says error. Right? It is thinking, okay, probably this print was supposed to be inside. So by mistake, it came out. So it is saying send it inside by putting it in a indented block. But this print is supposed to be outside only. But I'm not. I know something else has to come here. So in such cases, what you do is I simply say pass. Right? I know some statements are supposed to come here. I'm not yet ready with those statements, but I know not to lose track while building my logic. I want to put my while statement here so that I know that yes, I have to handle this when I further write code. In such cases, we simply put pass. Now this will not give error. It will simply ignore that. Okay, it says some condition is not defined. Some condition, let's say it's not. Same thing we can define what we have defined. Count one. It's a counter. That's that equal to 5. I'm clear with. Okay. In such cases, we use this pass statement. Now that's out of the way. Let's see what break and continue will do. Okay. Let's take this while true. Right? Under normal circumstances, this will not break. This will not stop after 5 times. If I execute this will go on forever. But again, I want to make it stop after 5 times while still using this while true. So again, I'll define counter is equal to say 1. I'll print this and then say counter plus assigns 1, increment the counter. If counter greater than 5, break. Okay. Use a counter, define a statement like while true, statement, increment the counter, keep checking the counter for your desired value. You desire the counter not to exceed 5 so that the statement will be printed twice. So if the counter value is going beyond 5, you say break. One, two, three, four, five times. What this break does is it simply breaks the loop it is in and comes out. Okay. Break statement breaks all the loops it is in and comes out. At the moment this break statement is encountered, it breaks this while loop and comes out. When this break statement will be encountered? When this condition is satisfied. Okay, that is break. Now let's say I have a. We'll take a more pragmatic example. So I have a list. Price list. Let's assume R stands for router and S stands for switch. Now you want to check whether this device contains all routers or at least one switch. Right? You're expecting this device list to contain only routers and not switch. Right? Even if one switch is encountered, you can say that this device list is not proper. Right? Let's say that's the expectation. So what you'll do, while true, this is better done with for loop. For item in device list, if item is, what should we do? Break. Before breaking, we'll say print. And then say break. Okay. To keep a track of what we are doing, we'll also print item. You see, it started from here. SR printed. This condition is not satisfied. Goes to the next item. R goes to next item. R. Right. It printed 3 R's. Then it came across S. Right. Printed S. Then check that this condition is matching, and we do not expect this some switch to be there here. So it's a reset. Yeah, device list is not proper. Now there's no point going on checking further, right? There's no point going on checking 5th or 6th item also. The moment we encounter one irregular thing, we know that yes, the list itself is not proper. So we can stop. So we say break. Right? So that is the use of break. Okay. We can achieve this in while also. You just have to put the appropriate logic. You have to say while true, then again you need to go in a for loop, right? So there's no point. So anyway, since for you have a list to travel, you anyway have to use for loop. even if you put it in a while. So that's the reason I thought, okay, why not use for itself? Suppose you have a slightly different requirement. This time it's like, yeah, you know that probably there are some miselements, right? Some SSF crept in. You want to count how many switches are there. Okay? You know that, yeah, there are some things, but just because you encountered one, you don't want to simply say that. You want to say, okay, there are 3 switches. I'm expecting all routers to be there. There are 3 switches. Okay? How do we do this? Got the problem, right? In first case, you're not expecting any these things to be there, switches to be there. So the first switch that you come, the first incorrect element that you come across, you can stop. You can stop and come out and say, yeah, this list is not proper. So in such cases, we use break. But now, slightly different requirement. Yeah, I know that there are some incorrect elements here, but I want to know how many incorrect elements are there. So what I have to do? Start processing. Is this incorrect? No. Correct element. Correct element. Correct element. Incorrect element. I know that this incorrect element. So what I have to do? I have to count. Okay. First incorrect element. Correct element. Correct element. Second incorrect element. Third incorrect element. Okay. And these incorrect elements, let's say you want to separate them into a list. So you'll say for item in device list. We want to separate switches into a list. So we create a blank list. If item S dot append item continue. So what this continue statement will do is, it will skip the current iteration. It will do this actions, skip the current iteration, immediately go to the next iteration. Okay. It printed only R's. You see, it didn't print S's. Because it after doing this, it encountered this continue statement. Immediately, it went to the next iteration. And at the end, we have this switch list populated. So all the SS, they are separately populated into this. Okay. So continue is, okay, start traversing the list. You have some condition. When some condition is met, take some action and then say continue, which means once this condition is satisfied, skip the current iteration, immediately go to the next iteration. So the statement which is coming after continue will not be executed for this condition. Because the moment it sees this continue, it skip whatever is after that and it goes here. Append is simply take this item, push it into list. Right? This is an item. Take it. This is a blank list. Take this item and keep pushing it into lift. No, it will be because we put this append inside the if. So only if this if statement is true, it will be appended. If that does not happen, right? Because we are seeing only SS in this. So R is not equal to yes. In that case, it doesn't go into this statement at all, and continue will not come across. So it will keep printing R's, right? R. All R's will be printed because for R's it won't go into this, and continue will not be encountered. So no iteration will be skipped as long as it keeps coming across R's. Okay. So that's about loops, for loop, while loop, control statements. Okay. So this is a problem which we can take and try to solve. Yes, this will also be sent. This is what we have precisely done. And we just checked whether is there any even number. If it is there, extract all of them. Okay. Next concept is functions. Right? Functions we have already seen. Right? Print, type, input, all these are built-in functions because these someone realized that, oh, these guys are going to be printing things again and again and again. So let's put all the statements which are required for them to print something into a function and let them provide it as a function. So simply call the function and get your work done. As the name suggests, function will help you to achieve certain functionality. In this case, input function, taking input, print function, printing something to the console, type function, getting the type of the variable, and so on. Right? Similarly, let's say you have a function to do something which you have not done. Like let's say you have certain numbers, you want to calculate average. Okay? You have this marks. Now, how can you find its average? For mark in marks. First you want to sum them up. This is sum is equal to 0 for mark in marks. Sum plus assigns mark. Take each mark and keep adding it to sum. First mark is 67. Add it to 0. So now sum is 67. Go to second value, add it to sum. 67 plus 89. Like this it goes on adding up numbers. Right? Once that is done, average is equal to, then we also have length, number of marks. Length of marks. Average is nothing but sum by number of marks. Sum of marks by number of marks. This is fine, but let's say you wrote so many other statements. Again, here somewhere down you need to calculate some average, right? What will you do? Again, you have to write this logic there. Instead of mark, let's say average salaries, right? Or let's say average fee paid by the students, per fee in fees. Right? So somewhere down again after some lines, right? You have some more requirement. You have one more requirement. You have another array like this, another list like this, and something else. Profits. You want to find average profit. Again, you need to take this code, put it here. So what are you doing? Have some lines of code which is being used again and again. Wherever it is being used, you are copying that code. Of course, you'll be changing it. Profits. Right? Which is not a very efficient or very good way. Right? Suppose suddenly there's a storm in mathematics and the way you calculate average has changed. You need to change it here. You need to change it here. You need to change it here. And wherever you are using this, you need to go and change everything. Right? Suddenly some Newton-like guy comes out shouting, "Eureka, I found a new way to do average." So your job is, your life is screwed. And you need to go and change in every place. So what we do, this is the ideal case to define this thing as a function. Right? We have a common function, finding average of what? Some given list. Right? In this case, it is marks. Let's write a function to find the average. When you are given a list of marks, I'll find average marks. When I'm given list of fees, I'll find average fee. When I'm given list of profits, I'll find average. When I'm given list of something, apples, bananas, etc., I'll find their average also by writing a function. Right? I'll put the same statements in a slightly different way. I'll say def, I'm defining something. Calculate average. I'm calling my function as calculate average. I'll be calculating average of what? Of some collection. You give me any collection, I'll find its average. since I'm defining a block, I'll put a colon. And then the statements which are used to define this, find this guy, I'll send them inside. Right? Now this is my list for item in some collection. I'll be finding length of that sum collection. I'll initialize sum to 0. I'll find the number of elements in that sum collection. For item in sum collection, sum is equal to sum plus item. Then average of sum collection is sum by num, and then print the average. Right? Now here I need to find the average of marks. So what I'll do, I'll simply call this guy. And what will I be passing? Whose average to be found? Marks guy. Right? Now here, so I'll add some statement using my formatted string. Average of the given list of marks I'm directly printing. So the average of the given list of marks is calculate average of marks. For fee, what will I do? I take these two statements, go down, and put them. Now I don't need these statements, right? There's just a repetition of the same code, so I'll delete it. Instead, what will I do? Instead of fees, I'll say now you calculate the instead of marks, I'll say calculate average of fees, and here I'll say fees. Same thing I'll do here also, right? But hope you got the point. Average of the given list of marks is this. Average of the given list of fees is this. Right? There's no duplication of code. Your logic to find the average is just at one place. You have defined it as a user-defined function. You are calling it wherever you require. That is the purpose of functions. You define once, you use it how many ever times you need it. Now, while defining, you need to define properly, right? What this function will act on what data. Inside that, you use that data. And when you are calling that function, pass the data whatever you want. Now this marks becomes this sum collection. Right? Here I'm passing, when I'm calling this function, I'm passing marks. That marks becomes this sum collection. And it goes inside, gets processed. What you get is average of what we pass. Same way here, this fees becomes the sum collection when this function is called with fees. Again, this sum collection is like a temporary variable, right? As long as when actually this calculate average is getting executed, this sum collection becomes marks. When it is called with fees becomes the sum collection. So it's just we call this as a parameter, some temporary name we give it to the object which we'll be actually calling, right? This marks, but because at this point I don't want to limit the capability of this function, but by saying calculate average of marks, calculate average. I want to make it generic, right? So I'll give it some generic name. You give me any list, I'll calculate its average. Okay, that is the concept of functions. You have some statements which you might have to be repeating again and again and again. In such cases, you push it into function. You push it into function, and wherever you want this function to be carried, call it. Now, the easiest way to understand functions is take this guy. Right? I need to print something here. I'm calling my print function. I need to print something here. I'm calling my print function. What am I passing here? Average. You pass average, average will be printed. You pass text, text will be printed. Same way, this is my function. Calculate average marks, marks average will be calculated. Calculate average fees, fees average will be calculated. Yeah. Okay. Now, normally, you see here, I'm finding average and printing it, right? Which means it just gets printed. Let's say I want to take that average and then do something, process it further, send it to some other program, push it to a database, use it in a report, right? I cannot use it because I'm finding its value, printing it, that's it, it's finished, right? So if I want to use this value somewhere else, what do I have to do? I have to give it back. I have to give it back to whom? Whoever is calling me. Because I am a function, I'll take some data, I'll process that data. When will I do all that? Just because I'm defined, I will not be doing any of this, right? Only when someone calls me, I'll be taking that data and doing something with that. So wherever someone calls me, instead of simply printing it, I will return it to them, whoever has called me, so that they can store this in a variable and then do something with that, right? So instead of printing this, I'll say return using a keyword called as return. What to return? Average. Why do we return average? Because our function is meant for calculating average. We have written a function to calculate average. It makes sense for me to return that average. To whom to return? To the place where the function will be called from. So now this guy, calculate average, he will not print the value anymore. Right? If I execute this, you will see that it's not printing anything because I've commented the print. Rather, it is giving me back a value, which means I can capture that value here. When I call this function, I get a value, which means I need to store it in a variable. What is the appropriate variable name for storing this? Marks, average marks, AVG underscore marks equal to this. Now, once I store this, I'll be able to do anything. In this case, okay. Now, same way here, this guy will return me a value, which means I need to capture it and store it in a variable. Appropriate name for storing this average of this piece is AVG underscore, let's say piece. So when I call this function, I get back a value because this guy is returning that value. The function is returning that value. So when you call that function, you get back a value. So you have to store it in a variable if you want to use it somewhere else. Okay, so I get like this because my function now returns these values. Okay, that was just a brief introduction to functions. Just think about it and try to convince yourself whether this is useful or not. Right. The other example I gave is, yeah, wherever I need to go on duplicating the code, which is a very bad way of coding. So instead, whenever you have some repeated thing being done again and again, define that as a function using the def keyword. The data to be passed to the function comes in these brackets. That name can be anything. Normally, calculating average. Of what you will be calculating average? Some collection of numbers. Right? So it's a numbers. Use that numbers inside. And you decide whether this function will return some data or not. Right? Let's say we are using a function to display some nice message or something. In that case, you don't have to return value. You print the nice message within the function itself. But let's say here you are doing a more thing, like you're asking your function to process data and send you back the data so that you can use it further. In such cases, you use return statement. When you use a return statement, this function, when you call it, returns a value which you have to store in a variable. Okay, there is some more concepts to be discussed about functions, which we'll do tomorrow, but we'll stop here for today and take any questions. Yes, recording is